Hello everyone, welcome to this video. In this video, we'll be talking about odd and even permutations. So what is an even permutation? A permutation, it is called even whenever we can express it as a product of even number of transpositions. As per our study based on permutations, we know any permutation could be expressed as product of two cycles, which we call usually by the term transpositions. Correct? So now we are saying if we have in total, we will count how many such transpositions would be there, and if that number is if that number is an even number, so in that case a permutation would be even, otherwise it would be an odd permutation. Correct? So here we have the cycle with us, which is a 3 cycle which maps 1 to 2, 2 to 3 and 3 to 1. So therefore, by the previous result, we know the proof of the previous result. We know the first element could be written as with the last element, and the first element could be written with the second element. So this is expressed in terms of transposition in this way. However, there are also another methods or another ways by which we can write a given permutation as product of permutations, but this is the standard way by which we can do so. And moreover, because both of these two cycles they are disjoint to each other, by the previous result that we have already studied, we can interchange both of them, and that does not make any difference. Okay, so there are we have expressed the same permutation into two ways, where in each of the two ways here we have even number two transpositions which are multiplied together. So that means we have an even number of transpositions with us, hence this permutation, this is an even permutation. As for the second example, let's consider an example here. It states that we can map the number 1 to 2, the number 2 to 4, the number 3 to 3, and the number 4 to 1. So this could be expressed in cycle form as 1 is going to 2, so 1 is going to 2, 2 is going to 4, so 2 is going to 4, and what about 4? 4 is going again back to 1. So this completes one cycle, and then 3 is going to 3 only. So this is just a single cycle, one cycle. So we have a 3 cycle, 1 to 4, and a 1 cycle, 3. Now we can decompose this 3 cycle into transpositions, again using the same rule, with the first element the last element, with the first element the second element. Correct? So we have 2 transpositions and one cycle. Okay, continuing with our example here, we know all the 1 cycles, they can be omitted, right? And so we can omit this 3, because if we are not writing any cycle, that any number, so that means it is mapping to itself. So we are left with these 2 transpositions, 1 4 and 1 2. So this is also forms an even permutation. Why? Because we have a product of 2 transpositions of such kind, right? Next, let us discuss what is an odd permutation. A permutation is called odd when we can represent it, decompose it, and write it in terms of transpositions, which is the product of now the odd number of transpositions. So we have odd number of 2 cycles with us. For an example, let's consider a 4 cycle here, where 3 maps to 4, 4 maps to 5, 5 maps to 6, and 6 map back to 3. So here we can represent it again in our standard form, where the first entry is written with the last entry, right? And the first entry is written with the second last entry here. The first entry is written with the second entry here, right? We can do so very easily. So you see, we have decomposed a given permutation as the product of these 3 permutations. So therefore 3 is an odd number, so therefore this is an odd permutation. As an example, let's consider the second permutation here, which is a 2 cycle multiplied with a 3 cycle and a 3 cycle. So here the 2 cycle is represented in the same way. We can decompose this 3 cycle into transpositions of this kind, where the first element is again written with the last element, then the first element is written with the second last element. Similarly for this transposition, so it represents the product of transpositions after decomposition. So in total we have 1, 2, 3, 4 and 5 such transpositions which are multiplied together. So you know 5 is an odd number, so therefore this forms a odd permutation here. So I hope you are clear with the topic of odd and even permutations. Well, that is it for this video. Thank you for watching.